Hello, Hacking Paris. Thanks to everyone who's watching now. In our talk, we're gonna analyze several examples of critical vulnerabilities in enterprise products. My name is Mikhail Kluchnikov.
I'm Igor Dmitrienko. Hello, everyone.
We work at Positive Technologies and we are members of the PT Swarm team. Our team does security research in all industries. Every our research is available to the community. You can read about them in our blog or on Twitter. We believe that critical vulnerabilities in enterprise software are like monsters in dungeon that can hide for years. The approach to cope with them involves the interaction of all sides, researchers, vendor, and clients. All the vulnerabilities that will be described in our talk were responsibly reported to VMware. Vendor has released the patch in a timely manner, which minimizes the risks for a client if he installs the patch as soon as possible. Today, we present 5 exciting stories about critical vulnerabilities in enterprise products that can be exploited by unauthenticated users. We are starting our presentation with the unauthenticated RCE in the VMware vSphere. You've probably seen this software on the internet or in the internal organization's network. A login page of the web panel can look different. It depends on the VMware vSphere version. For example, you could see this, or this login page of vCenter. vSphere and vCenter enable the virtualization of corporate infrastructure and provide means of control over it. While this software can be encountered on the perimeter, in most cases it's located on internal networks. In February of this year, VMware fixed a critical vulnerability in vCenter that allowed an unauthenticated user to execute shell commands on the target system. According to threat monitoring at Positive Technologies, there was over 6,000 VMware vCenter devices worldwide that was accessible from the internet and contained the RCE vulnerability, and most of the servers were in the USA. During the analysis of the vSphere client, we employed both the black box and the white box approach to testing, as usually focused on the vulnerabilities that could be exploited without any authentication. From the web panel, we tried to send as many different requests as possible, all without cookies header. After sending an unauthorized request to /UI/ROPS plugin UI REST services, we discovered that it didn't in fact require any authentication. The web application relies on plugins, usually located in separate jar files. For some of its features, the ROPS plugin UI plugin, for example, is implemented in the file ROPS plugin service.jar. From what we understand, each plugin must specify which of its endpoints require authorization in the web panel to run and which do not. This plugin was configured to allow unauthenticated users to access any URL it handled. We have started analyzing the jar files we are interested in. The upload over function responsible for the URL /UI/ROPS plugin UI/REST/services/upload over piqued our interest. The handler for this path performed following actions. Firstly, received a post request with the upload file parameter. Then read and wrote the content of the parameter to the input stream variable. Opened the resulting data as a tar archive, retrieved all the archives entries, and while iterating over all the entries, a copy of each current entry was created on disk using the file name convention /tmp unicorn over dir plus entry name. This was where we noticed that the names of the tar entries are not filtered. They are simply concatenated with the string /tmp/unicorn over dir. File is created at the resulting location. This meant we could create an archive entry containing the string .. which would allow us to upload an arbitrary file to an arbitrary directory on the server. At this stage, we theoretically could upload arbitrary files to arbitrary folders, and then we needed to find a place on the system where we could upload the GSP file and execute it using a HTTP request from an unauthenticated user. In our search for a candidate location, the folder stats report in which GSP files are located looks promising. The check for unauthorized access to GSP scripts yields success, so you can see it on the slide. Let's check whether WebSphere UI user has write privileges to the directory. And sure enough, it does. Great. Now we have uploaded a specially crafted GSP file to execute commands on the system. Let's create an archive containing our craft JSP shell payload and send it to the URL that we are studying. We created a JSP script that executes commands from cmd get parameter. If target Windows machine has enabled Windows Defender, then you need to use some obfuscation techniques to save a malicious file on the system. To make a tar archive, taking advantage of this quirk, we used the evilarch utility. The resulting archive contained a file with the name with path traversal. So we generated archive with our GSP file and uploaded it on the system. And then we tried to invoke the JSP script through get request with the cmd parameter value as who am I. And boom, we got an RCE with NC authority system privileges. Based on the work with this vulnerability, we would like to note two things. The first, it is necessary to combine both approaches to test to the analysis of a web application, if you have such an opportunity. The second, any parsing of files or conversion from one context to another in the application is an important point, since security errors are often possible here. The next software we will talk about is the VMware View Planner. You will see the details of an RCE from an unauthenticated user. VMware View Planner is a utility for comparing virtual desktop deployment platforms. View Planner generates a measure of client-side desktop performance for all desktops being measured on the virtual desktop platform. The web management interface is available to users after the starting of the VMware View Planner utility. Web panel is working on two ports, 443 and 80. Our analysis has begun with the search for the processes that was work on the port 443 and accessible from external network. We executed the command netstat -pltn on the system to find out the process we are interested in. The port 443 is a Docker port. Next, we require to get a list of all running Docker containers and ports used by them. So we executed system commands docker ps for getting this information. As it turned out, ports 80 and 443 were forwarded from the Docker container named Apache Server to the host system and available on all interfaces. It means the web panel that was accessible to us at the beginning of the research was deployed in a container. It is logical that next we got access to the shell of the Apache Server container and found the processes that listen the port 443. It turned out to be an HTTPD web server. Next, we analyzed the web server's config located in the directory /etc/httpd/conf. Our attention was caught by the line with WSGI script alias, which means that path/log_upload is handled by the Python script log_upload wsgi.py. And what was important, authentication was not required to send a request to this path. We have drawn up the small schema for understanding how the GET request for the path/log_upload has handled. The HTTP request comes to the external 80 port on the VMware View Planner server. The external AT port is the same port as the AT port on the Apache server Docker container. The Apache server inside the Docker forward HTTP request to WSGI's Python script, and the script log upload WSGI handles the request. Next, we started analyzing the script log upload wsgi.py. This file turned out to be small and easy to analyze. The application worked as follows. It accepted a post request, parsed it, composed a path based on a static string, and received data. We would like to note that without any filtering. And then created a file with the generated early path and the content that were parsed from a request. We were surprised that the received data is not filtered in any way, which means we can write an arbitrary file to an arbitrary directory using path traversal, or a feature of the OS path join function in the Python language. We created a Python script that could allow us to execute arbitrary commands on the server. At this research stage, we required to find a path on the local system to upload a file which could be executed. Without thinking twice, we decided to override the current Python script with content that could allow us to execute arbitrary commands on the server. To do this, we created a Python script with malicious content which received the command from the post parameter and executed it. And then we tried to upload it to the target system. The upload was successful, and thus we got arbitrary commands execution on the system with the privileges of Apache user. Summing up, we noted the following things. The first, sometimes you don't need to search for a folder for uploading a file. You can just overwrite an existing script and get an RCE. And the second, you need to be completely sure in your exploitation. Sometimes you only have one try.
Thank you, Mikhail. Now we're going to the next software. Carbon Black. It is a part of security software that's supposed to make the infrastructure secure. We found a way to bypass an authentication and get access to an administrative panel. If you look at architecture of product, we can see the following. There is a fancy proxy server Envoy on the front side, which passes the request further to the internal microservices in Java. Pretty much common things. Let's open the configuration file for Envoy server. At the first glance on the Envoy server configuration file, we notice that the role-based access control model in use and come across to an unknown role called the service user. We notice that his permission is unlimited. So move on, trying to identify the service user. We examine the Java Service API and find there is a way to create JSON web token for so-called service user. Interacting with Java services, we call this method and get token indeed. We try again to perform the trick, but from an external network through the Envoy proxy server, and we fail. Let's dive into code again and figure out how the Envoy server handles the roles. Here we have to focus on the following two lines. The first one is a blacklist rule, and the second is white. We need something that matches both rules, some feature of Envoy server. And we found one. The documentation tells us that Envoy server doesn't normalize characters in the URL by default, according to RFC. In other words, when Envoy server passes the request, these two lines are not identical. So, if we perform URL encode of any characters in the previous example, we could bypass the both rules and communicate with required API methods. Once again, we encode S letter in the previous URL path and thus bypass both verifications. Perform request and get the super user JSON web token in response. So now we are the service user. Here's a demo. We're trying to call the initial API method, but fail. You try again, but use your own encoded S later. We receive a token in response. And now trying to call another method to verify the token. Done. We have access to another API method. And what was that? It was just a miscommunication and incoherence of two servers. For the last few years, there are dozens of researchers and CVEs related to this problem of incoherence between servers. So the documentation is a clue. It shouldn't be overlooked because it is the only way to avoid this type of vulnerability. So the next software monitoring and control the virtual infrastructure. As a result of research, we have found a vulnerability chain that consists of three stages and lead to remote code execution. We'll look at vulnerabilities separately in order to emphasize the role of a specific vulnerability as the element of chain. We're going to start with the SSRF, which means server-side request forgery. We started examining public API and came across the interesting methods, which return fingerprints of nodes by their address. Passing out a remote address, we get a request to our netcat server. As the next step, we launch HTTPS server and figure out that we also can control the URL path of SSRF by passing question mark in URL. So at that point, we were able to perform any GET request by means of vulnerable application. We started digging into internal API to figure out if we can catch anything worthwhile. In this way, we managed to receive hash of an administrator by abusing password replication functionality. User admin is also associated with the system user on server. If we restore the password, we're able to connect with this user by the SSH, in case it is enabled and doesn't use key-based authentication. Password was sorted and hashed by SHA function, so it wasn't too complicated to restore it from hash. It's also worth to say that the best practice is to use so-called slow hash functions, especially when we talk about the administrative user. Of course, they also can be cracked, but as they are designed to be inefficient, it requires more effort to restore them. This approach has a high probability to obtain administrative control on server, but is there something more guaranteed? Let us look more closely at how the application handles requests. We see that application crafts a new GET request from our parameters, but how get an access to the private API methods, which requires an authentication. There are a few mechanisms that could allow it, but in this specific case, chosen implementations wasn't secure enough. So every time the vulnerable API method was called, application sent HTTP request with basic authentications in the header. As for credentials, the maintenance administrator user was used. It's a super user in this application. So there was only one credentials for each internal HTTP request. It's easier for us ask the application to visit our remote server, where we can steal the headers from an HTTP request. We set up our SSL server and steal the credentials by setting SSRF to our evil server, which parses incoming headers. We may see the request headers in the response and in our server logs. So now we become a super user. In order to escalate these findings to remote code execution, there are two ways. The first one is too rough and may lead to non-functioning because we need to reset administrator password. The second way is more gentle because we found a path reversal vulnerability, which led to arbitrary file uploading and eventually to remote code execution. Here's an example of the first approach. By the way, if you're an ethical hacker, we don't recommend to use this method on two clients. We perform administrator password reset, and because there is the same name user on the server, we simultaneously change his system password too. We enable an SSH service and thus get access to server through SSH client. For the second way, which was mentioned as gentle way, we found an API method vulnerable to path traversal in file upload functionality. It means that we could upload any file in any arbitrary directory. So we use it to upload a web shell into a web directory and get remote code execution again. Here's the main idea that even a vulnerability with low severity may go off. So take care of all of them. We move on to our last story. First of all, we would like to emphasize that this software was almost retired. But despite of that, vendor released a patch in a few months without any excuse. We really appreciate it. This is a software for analytics and measures in infrastructure. And we found an update functionality without any authorization and authentication. Moreover, the administrator could set custom repositories. The update mechanism was based on manifest files, which describe how the update will proceed. The post-install script and pre-install script fields describe the system commands, which are executed during the update. This is a place where malicious code can be placed. The update process consists of three steps. If there is manifest file in the remote server, it will be downloaded and used in the update. The only challenge we had was the signature mechanism. The application wanted to see the signature of manifest file in order to start update. Lack of time didn't allow us to solve this problem fast, so we just found a way to bypass this verification. If we open the source code, we can notice that the parameter URL isn't properly parsed and is used as is. We see that we can inject new fields into the XML. This XML file is responsible for pointing to a remote repository and tells how to communicate with it. We set a HTTP request, passing URL parameter and injecting an additional property, which tells the application to disable the verification. As a result, the signature verification was disabled. Putting it all together. First of all, we create custom repository on the remote server. We just need to set up the HTTP server that contains the manifest file. At the second step, we create the manifest file and upload it into the web directory of our repository server. The manifest file will write the code which will be executed on the vulnerable server. So the next step, we set the remote repository URL and disable the signature verification. At the next step, we send HTTP requests and tell to application perform the update. So as a result, command from manifest file is executed and we get remote code execution. Here is a demonstration of exploitation. In this demo, we copy a shadow file into the web directory. So prepare our manifest configuration, set the last version. As the next step, we're going to set up the repository. Set our custom repository. Verify. And start to install. And it's done. We copied a shadow file into the web directory. The key point here is that the old software must be maintained till the end. Don't forget about it. It was the last story we wanted to tell. In conclusion, we'd like to note important points which were discovered during our work and which are fundamental in making worlds more secure. First of all, each party have to act together. Researchers should make a responsible report to vendor. Vendor have to provide patches in time and to be open to researchers. Clients are also responsible for software they use. Have to check for updates and timely install them. In our opinion, it is the only way for safety. And as a second point, we'd like to emphasize the following. Many security fixes by vendor doesn't always mean a bad software, but the opposite, that it cares about clients and their security. And that's all we had for you today. We want to thank VMware and their security team for responsible cooperation. And of course, thank you Hackam Paris for letting us share our stories.